Orientation slip is a common strategy in daily life. Here, a person opens a toaster oven door. As it starts to rotate, the hand naturally slips to prevent awkward postures that are induced by the hinged motion of the door. If the person chooses not to slip, it leads to large, undesirable motions. There are many examples where a similar strategy might be natural. In many cases, an underlying constraint causes a person to use a slip strategy. We desire to use human demonstrations that often contain orientation slip to guide robot actions. Here, the demonstrator uses instrumented tongs that measure both pose and interaction wrenches. In this work, we present a method that can identify prehensile orientation slip in constrained interactions. Our method is able to determine the constraint type, parameters, and orientation slip properties using nonlinear optimization coupled with hierarchical model selection.
Our hierarchical model selection consists of 3 steps. First, the base geometry is selected by fitting a subset of the constraint equations. Second, the articulation models, which include the slip model, are evaluated based on orientation and moment residuals from the fitting process. Finally, we use an estimate of the kinetic friction from the instrumented tongs as additional evidence for the likelihood of each articulation model. The final articulation model is selected by combining these 2 evaluations.
We conduct a user study to evaluate our methods. We observe users interacting with a variety of constraints to evaluate how often and with what interactions an orientation slip strategy is used. We show that our method can differentiate between different interactions with the same geometric object. In summary, we provide a method for identifying constrained prehensile orientation slip in human demonstrations. By conducting a user study, we demonstrate that this strategy is used in a variety of constraint interactions and show that our method can identify orientation slip from human demonstrations.